So we're going to start our coverage of the real meat of the content of the course with an overview of Spring and Spring Boot, which are the platforms, the web platforms we're using as the basis for all the assignments in the class, which, of course, as you'll see, are also going to be providing a nice understanding of how to do microservices in modern web-based platforms. So you can find out more about Spring by going to spring.io/projects, and you'll see there's a lot of stuff in Spring. We're going to be focusing primarily on Spring Boot, which is just a piece of it. And you can see that it's what's called an opinionated view. And I'll explain what it means to be opinionated here in just a moment. We'll also talk about some of the key components in Spring Boot. And this is actually very reminiscent of almost anything you would find in modern web programming environments. These concepts are not limited to Spring, but Spring is a good example of how to do this. There are obviously other environments you would have for other languages, like JavaScript or C# that might differ in some of the details, but the architectures are typically very similar. So Spring is commonly known as a dependency injection framework and an inversion of control container that's widely used to develop web apps using Java. What does it mean for dependency injection? What does that mean, or DI as it's called? So dependency injection is a pattern and really a framework. It's really more of a philosophy, if you will, that enables an object or a service to receive other objects or services that it depends on. So you would have some kind of client. It doesn't have to be a client in the client-server sense, but just a user of some services. And some client needs some service or services in order to do its thing. And the injector is responsible for detecting what service or objects the client needs and then injecting them into the client. And the way this is done is by using something called a blueprint or a recipe, where you don't have to, you, the programmer, application programmer, don't have to think a lot about how things are configured or injected. You just have to worry about saying what it is you need. And the framework is responsible under the hood of doing the injection on your behalf. So dependency injection enables what's known as auto-wiring in lieu of manual wiring. And you'll see auto-wired is actually an annotation that's used in the Spring framework to tell the framework, hey, this particular field depends on something else. Go find that something else and connect those things together under the hood so you don't have to do that yourself. And the basic motivation for dependency injection is to separate concerns. You'll see that one of the themes, one of the key meta patterns in software development, modern software development, is separating concerns from creating or constructing objects from using them. So we want to be able to decouple the creation of something from its later use. That's actually a pattern from the good old Gang of Four book. Hopefully you learned that when you took CS 3251, called the factory patterns, factory method, abstract factory, and so on and so forth. And so dependency injection is really just that concept, automated in the form of annotations and a framework that populates and injects the pieces together. And the goal is to be able to have a more loosely coupled piece of software or set of software components. Loose coupling means there's less interdependency, less coordination, less information flow, and in this case, things can be done automatically, as opposed to tightly coupled, where there's lots of interdependency, lots of coordination, lots of information flow. So modern microservice-based approaches are heavily dependent on configuration and dependency injection. The next concept that's important in Spring is inversion of control, or IOC. And the basic idea of inversion of control is to make it the framework's responsibility to keep track of the threads of execution, thread or threads, rather than making it the application developer's problem to do this. This is a very, very, very common thing in modern platforms and frameworks. Now, we're going to talk a lot about inversion of control in a more technical sense, but at a high level, it implements something known as the Hollywood principle. And you can read this link on my website about what the Hollywood principle is. Basically, the Hollywood principle is, don't call us, we'll call you. And so you, as an application developer, define components, and then Spring figures out how to wire them together and register them with the underlying framework. And you don't have to be responsible for writing the control flow except for the methods that you implement that do business application kinds of stuff, or application-specific stuff, or so-called business logic. So that's what the Hollywood principle is. Spring contains a bunch of projects. We care about Spring Boot, and in particular, right now we're going to focus on Spring Boot 2.0, but Spring Boot 3.0 has just been released, and so I think actually starting maybe with assignment 1B, we'll have Spring Boot 3 as the basis of this. From the point of view of what we're doing, it doesn't really make that much of a difference. There's some new cool things and improvements that they've added. But the key point is that there's two primary stacks in Spring Boot 2.0 that give you synchronous capabilities. That's what's called the servlet stack, and asynchronous capabilities, which is called the reactive stack. And so we're going to focus on both of those, starting with the more traditional synchronous servlet stack, or what's known as Spring Web MVC. So let's take a quick look at some of the key components in Spring Boot that are used to create standalone production-grade web-based applications. And this is just a nice little diagram. You can find that diagram on the web. So we typically have a client or clients, and usually those will either be browser-based, very, very common, mobile, standalone, which could be things that would run, say, as a native program on your desktop, becoming increasingly uncommon, but like Microsoft Word would be an example, and or console-based clients, things you could run from the, quote, command line. Some of the tests we'll show will be console-based clients. And they're going to end up sending requests from the client to the server or servers. And those requests run atop the Hypertext Transfer Protocol, and usually the Hypertext Transfer Protocol secure, HTTPS. So these are HTTP requests. And as you were probably familiar, there's several different types. There's GET requests, and PUT requests, and POST requests, and update requests, and delete requests, and so on and so forth. So HTTP is a request response protocol that's used as the basis for client-server computing, and Spring does this like many other platforms do as well. When a client talks to a server, it's really talking to something called a controller, which is just kind of a funny name. But what it does is the controller is responsible for taking in the HTTP requests from the client and then routing those requests to so-called endpoint methods or endpoint handlers that handle the requests. So the controller's job is really to serve as some kind of an adapter that takes in HTTP requests and then converts them into method calls on the appropriate piece of Java code. And usually, and in fact almost always the case in this class, the controller is going to talk to something that's called a service. That's part of the, quote, service layer. And the service layer is really where the business logic gets done. Business logic is used in quotes. It's the application stuff you have to write to pass your assignments, if nothing else. So that's where you put your logic that you're implementing the code. The controller is this kind of intermediate thing between HTTP and Java. The service layer is typically written in Java, and it will then access other pieces of the pie, like you can access the database, and you can access other services. So as we'll see when we start looking at assignment 1A, and if you watch the video, you'll see this, controllers and services can be connected to themselves and to each other and to other things they need automatically using dependency injection. You can tell Spring, I need to get auto-wired to something that matches this interface, and it'll go ahead and find that thing and connect them together, assuming you implement things correctly. Then there's also another layer called the model layer, and we're going to cover that later in the course. The first assignment uses a very, very simple model layer, which is just an in-memory map or list. But more generally, in production applications, your model layer provides access to persistent data, so some kind of database. And initially, when we get to that part of the course, we're going to use the Java Persistence Architecture, or JPA, in order to provide access to the database. And you'll see that one of the nice things about this is it supports really cool object relation mapping abstractions, so you can access the contents of a database much like you're making a method call on an object without having to know a lot of the nitty-gritty details of how the data is organized in the database. The interactions between the controller and the service and the model are typically just Java method calls, although, of course, you can also encapsulate other things. For example, you can make SQL queries into the database, either using Java or some kind of conglomeration of Java and SQL. The good news about this architecture is, for the bulk of what we're doing, you just write Java code that looks like good old Java code, and other parts of the system handle the transformation between HTTP requests and/or database-style programming. But we can program more or less as though these were standalone applications, which makes life a heck of a lot easier from a design and implementation point of view. So that's the end of our overview of Spring and Spring Boot.